Every primate that came before you could see almost perfectly in near total darkness. You can't. Something happened deep in your evolutionary past that quietly took your night vision away and traded it for something you've never once thought to question. Around 30 million years ago, in the forest canopies of what's now Africa and Asia, a small group of primates made a trade they never consciously chose. Most mammals on Earth run on two types of color receptors. Two is enough to tell a ripe fruit from a rotten one, most of the time. Enough to survive. But our ancestors' eyes mutated. A third type of color receptor appeared. Suddenly, they could see a color most mammals never will. The difference between red and green. That sounds small. It wasn't. It meant spotting a ripe red fruit against a wall of green leaves from 30 feet away, while every other animal in that same canopy saw the exact same shade of gray-green. An entire food source, invisible to almost everything else in the forest, visible only to them. But a third color receptor doesn't come free. Every cell your eye builds for color is a cell it didn't build for something else, seeing in the dark. Here's the part almost nobody explains, right? Your retina runs on two kinds of light-sensing cells. Cones handle color, but only in decent light. Rods handle everything else: motion, shape, brightness, and they're what let you see once the lights go out. You have about 6 million cones, and around 120 million rods. A cat's retina is packed even denser with rods, tuned for near darkness. So is a mouse's. So was your ancestors, once. When our eyes rebuilt part of that real estate for color, rod density dropped. And there's a second piece almost nobody's heard of: the tapetum, lucidum. It's a mirror-like layer sitting behind the retina in cats, dogs, deer, nearly every serious nocturnal hunter on the planet. It's why their eyes glow green in headlights. Light passes through the retina once, hits that mirror, and bounces back through a second time. A second chance for every rod cell to catch what it missed the first pass. Primates don't have one. We never got it back. So somewhere in that trade, 30 million years ago, we gained a color no other mammal in the forest could see, and gave up the reflective backup system almost every real nighttime predator still carries. Here's where it gets strange. Not every primate agreed to this trade. There's one exception, and it's the only one. The owl monkey, a small, wide-eyed primate from South America, is the sole nocturnal anthropoid primate alive today. At some point in its history, it walked the trade back. It gave up most of its color vision, rebuilt its retina for rods again, and went back out into the dark. It's the one primate that looked at 30 million years of trading color for night vision and reversed it. Every other primate lineage, including yours, kept the color, and kept the vulnerability that came with it, which raises an obvious problem. Long before flashlights, before candles, before controlled fire, the night still happened, every single night, for millions of years. So how did a species with mediocre night vision survive that, surrounded by animals that could see it perfectly? Not by seeing better, by switching senses entirely. Hearing sharpens first. In total darkness, your ears do something your eyes physically cannot. They tell you exactly where a sound is coming from without needing a single photon of light. Smell does something even stranger. It performs in pitch black exactly as well as it performs at noon. Darkness doesn't touch it at all. And there's a behavioral trick too. One you can still watch in almost every mammal that sleeps in groups. Huddling. Fewer eyes need to stay open when everyone else's back is covered by someone else's. Controlled fire changed the math eventually, but that came far later than the vision trade-off itself. For most of human evolutionary history, the strategy wasn't better eyes. It was better ears, a working nose, and knowing exactly which sound in the dark meant nothing, and which one meant everything. Here's where it gets uncomfortable, because none of this stayed in the past. Your eyes still need roughly 20 to 30 minutes in total darkness before your rod cells fully take over. Scientists call it dark adaptation, and they can measure it precisely. Your visual sensitivity increases by a factor of nearly 10,000 over that window. Militaries know this cold. Pilots and soldiers, preparing for night operations, sit in darkness for 30 to 45 minutes beforehand for exactly this reason. There's no shortcut around it. Which means that jolt of unease you feel in the first 60 seconds after a light goes out, that's not irrational. That's 30 million years of a very real vulnerability, still sitting inside your nervous system, waiting the same 20 minutes it always has. Modern life almost never gives your eyes that window. Streetlights, screens, hallway nightlights. We've built a world where true darkness barely exists anymore, so the adaptation rarely gets to finish. Which means, in a strange way, you are less adapted to real darkness than the ancestor who made this trade 30 million years ago. They lived inside it every single night. You almost never do. So the next time a room goes fully dark and something in your chest tightens for just a moment, that's not a flaw. That's the exact price your ancestors agreed to pay for the ability to see one red fruit on a green branch, millions of years before either of you existed. You got color. They gave up the dark. And somewhere in your eyes, that same trade is still being made, every single night.